Hi ladies and gentlemen, good morning and welcome back on the channel for a new episode of this Saving Private Ryan diorama. The central piece of this diorama, of this project, is without any doubt the Ramelle's bridge, where the final scene will take place, and that's what we will try to reproduce. So this bridge on the picture, and as you can imagine, the size of this thing is quite substantial. So at first my principal concern was to define which size would be this beast. And this will bring us to the first point: where can we find information regarding the size of this bridge? And guess what? On the internet you find absolutely everything. I managed to find the company who built this bridge for this specific movie. The company's name is Maybe Bridge and is located in the UK. And what you see here is our Ramelle's bridge being constructed. And for my biggest happiness, the size of this beast is published. So as you can see here, the bridge is built using different modules. You have the entry and the exit, and then you have the main span, if we can say that. So the entry and the exits are done with modules of 6 meters long, while the three main span are 12 meters long. The width of each module is 1.7 meters. Once the modules were in position, they just create a fake bridge around these modules using cement, hessian, and timber cladding. What is really cool is that once you've got one dimension, you can evaluate all the other measurements you need just by applying the proportion ratio rule. There is another dimension which is known and published on the internet, and that's the Tom Hanks height, 1.83 meters. The last dimension that I found on the internet that was useful was the tramway track width. At that era, the standard railroad or tramway track spacing was 1.43 meters. With all these dimensions, I was able to reproduce a plan of this bridge. So basically I did one side view and one top view. Once this step completed, the next challenge was to find the correct material to build this bridge. There are many ways to build a bridge or any type of building. You can use cardboard, wood, plastic, resin, or XPS foam, and that's what I decided to use. Let's have a few words about XPS foam. XPS foam is not that easy to find, at least for me living in Portugal. This foam is extensively used in the construction sector to insulate houses' roofs or pavement and things like that. And given I live in hot countries where the meteorology is quite favorable, insulation products like this are difficult to find. You might think, yeah, let's order on the internet. But the problem with this product is that due to its volume and its weight, the shipping costs are very, very expensive. There is another issue with this product. That's the fact that there is many different types of foam, and what we are looking for is a high density XPS foam with at least 30 to 35 kilo per cubic meter. If you are unsure or unable to find the density reference for your product, you can look for the compressive strength values. Both density of the product and its compressive strengths are linked. So if you find the compressive strength, you should look for something around at least 300 kilopascal. This is very important and necessary to be able to sculpt the surface of this foam and to reproduce realistically bricks and blocks, things like that. Should the sculpting not being necessary, in that case you can go for any type of foam. If you want to be able to cut this foam, I highly advise you to buy the Proxon hot wire tool. It's not that expensive. I think it costs around 100 euros. It's a very nice tool, very precise. The only drawback is its size. It's not done to cut large panel. And as I mentioned, these XPS foam are construction materials, and as such they are mostly delivered in big panels of 1 meter at least. So finally I managed to find this product here in Portugal and not far from my house, luckily. Many thanks to my friend Tiago who helped me after more than 1 month of research. But as you can see, this big blue panel is really huge. It's about 1 meter and 25 centimeters, and its thickness is about 8 centimeters. I wasn't able to find other sizes, so I had to do with this kind of format. The Proxon hot wire tool is able to cut up to about 15 centimeters of XPS foam. The only issue with this hot wire machine is that its working surface is too small. So at least work with such big panels. You have to know that while cutting XPS foam with a hot wire, any small deviation during the cut process can leave big damages and ruin your piece of foam. So as you can see on these images, I had to build myself a support table with some MDF wood sections and applied this support all around my machine. I also constructed an aluminium ruler just to be able to guide these huge panels on the machine. As you can see on these pictures, my first attempt with XPS foam and the thermocut are rather approximative, and I must confess that the cut weren't perfect, far from that. I had to start again and again and again some parts until I reached the correct cut precision required. I left anyway some parts unperfect because these parts would be hidden afterwards by the pavement. So what you see here is the way I work to create this bridge with XPS foam. I will now detail you a little bit more in 3D with some sketches how I organized and I planned my bridge construction in advance to make it as easy as we could. So the first and main module was the main bridge span, and for this module I had to work with 4 layers of XPS foam, given the foam I found on the market was only 8 centimeters width. The 2 outer sections had to be a little bit taller just to include the stone walls on the sides of the bridge. That's what you see me cutting now with a sharp hobby knife, removing the excess of foam just to leave the stone wall visible. As you can see, the pavement structure will be done afterwards with modeling clay. I wanted to have the lateral sides of the bridge in one single piece of foam, just to be able to sculpt all the details of the little stones and the main bricks. The only drawback of this method is that I ended up with 3 gluing seams in the middle of the bridge to make the junction between each foam section. For the upper part it wasn't a big issue because, as I said, the pavement in clay, in modeling clay, would come hide everything, but the problem is that on the bottom part of the bridge these gluing seams would be visible. You can clearly see here my lack of experience in the foam cutting techniques, but anyway I managed to do it, and afterwards I correct this little imprecision by sanding the foam, which is also a nice advantage of this product. This bridge also includes 2 triangular extensions on both lateral sides, so I built this triangular extension with XPS foam as well. I thought it was easier to make it on this modular way, cutting each pillar one by one. And that's precisely why a top view plan is necessary. So I cut 4 blocks of foam of the same size, just to report my drawing on the side of these blocks, and then cut the blocks with the thermocut. Looking at some footage references, We can also see that this triangular extension had an open part on top. So it was necessary to work with precision the connection between this triangular extension and the main bridge span. This open space on top was then drawn at scale, and I removed the interior with the hobby knife. The bridge pillar foundation were easy to do, no big problem with this. It's only 2 blocks of foam cut with the thermocut that will be positioned below the 2 main pillars of the bridge. My diorama won't reproduce the whole bridge, but only a fraction of it. I've decided to reproduce only the entry on the German side, where basically the Tiger One entered the bridge, until more or less the middle of this bridge. So the last element missing was the entry on the German side. On this side, nothing significant, only 4 blocks of foam, 2 for the stone walls on both sides of the bridge entry, and the 2 others for the main concrete parts. Just like for the bridge main span, the pavement will be done with modeling clay and will cover the concrete main block. Okay, now that we have all the main sections done, it's time to increase a bit the level of realism. Looking carefully on the bridge, you can see that some parts have suffered destructions. A complete bridge span has also been opened close to the Kettenkrad position, as you can see on this picture. So a complete wall is missing, and that should be reproduced on the model. During the conception, you see here with the Mabe bridge that this section in the middle has been removed on purpose. A great advantage of the XPS formwork and the thermocut is that it's quite easy to reproduce these destructions after the construction of the module. So you see here that the small destruction on the side wall at the entry, and the biggest destruction on the complete bridge span in the middle of the bridge. And there you can see that we are approaching the tramway tracks. These are the 2 black lines drawn on top of the bridge that you can see here. So that will imply further detailing works regarding these tracks, but I will explain that later on. I decided to give a little bit more texture to my XPS foam before assembly. So for this I created this pastry roller on which I put some PVA glue and then some gravels just to have a kind of texture printer, let's say, and it works quite well, especially for great surfaces. I'm now planning to create 2 or 3 other ones, smaller ones, for detailing smaller parts. But basically you can roll the surface you want to create these kind of little holes and texture frame on your piece of XPS foam. That's the reason why I decided to postpone the assembly of the bridge as late as I could. I thought it was much easier to manipulate all the parts individually, but also to be able to reach all the bridge location with the tool. To simulate the sagging of the pavement due to the repeated passage of military convoys, but also some heavy tanks, I created ruts with sandpapers and furthermore with a torch. Watch out when using a torch with XPS foam, but with caution it works pretty well. And these ruts, this sagging at some points on cobblestone streets is a common feature, by the way, that you can observe on old streets. This is also the reason why I decided to work with modeling clay for my pavement, my cobblestones. It's just because I found it much more natural and easier to create these sagging effect than working with XPS foam. To reproduce the top part of the stone walls of this bridge, I also used XPS foam. As can be seen on the pictures, This top part of the stone walls has been covered with large rectangular stones. So I then reproduce at scale these stones one by one, just cutting stone by stone in a sheet of XPS foam, having the right thickness. And as you can see, I do not measure each stone, so I wanted to keep this more natural looking aspect of having stones of different sizes, just keeping the thickness as a reference for all these stones. All these stones were then glued with PVA glue on the bridge. I then sent them to give them these rounded aspects before using my pastry roller to give them a little bit of texture. What you can see here is the result after sanding. So to reach the correct curvature, I already gave some hobby knife cut here and there to give a more irregular pattern, a more realistic look. And this is a more advanced stage with a little bit more of a sculpting effect with the pastry roller and with the hobby knife. I create some scratch in the stones. I broke some stones, and the pastry roller created the structure. Before sculpting the bridge with the hobby knife, it was necessary to use the reference picture and to report some dimensions on the bridge, just to try to approximate as much as we can the movie bridge. The lateral sides included three main parts, the arches, then the middle section with bigger stones, and finally the upper part with the smallest one. Okay, in order to keep the more natural looking aspect for my bridge, I just give some reference mark on the foam, but I then draw my lines like this without ruler to reach a more irregular aspect. I also draw all the single stones visually without any ruler, just by assessing the visual aspect of each individual stone on the real picture. I proceeded the same way for the intermediate section with the larger stone, a bit more rectangular. So just drawing the first reference mark on the lateral sides of the bridge, and then drawing each stone individually without any measurement. The idea for me for a natural stone bridge was to keep the aspects as irregular as it was possible. For the last upper section with the smaller stones, the idea was to be even more irregular. So I draw first the biggest blocks completely at random without any type of logic, and then I filled the spacing in between them. I think I could have chosen an easier bridge. That one obviously has thousands of little stones on his upper parts. Yes, I have a lot of work still ahead, not only to draw all these little stones individually, but also afterwards to sculpt them. But anyway, I found it more interesting to draw all these little stones before sculpting, just to help me win some time during the sculpting process, and also to avoid any mistake during this cut procedure within the foam, so to avoid any damage in the foam piece. I will develop the sculpting procedure in my next video. What you can see also here on the bridge on the upper side are the cut done to accommodate the railway section, the tramway sections. I already mentioned in this video at the very beginning that this bridge included a tramway section that you can see here passing below the Kettenkrad, and obviously we need to reproduce these tracks. So to start with, I bought this European gauge straight and rail and curved rail from T-Model. Now curved rail, basically in the box, these are straight rail, You can bend them to achieve curved rails if you need to, but that was not necessary for me as the complete section was straight. The box includes 4 sprues with straight tracks, but these are railroad tracks, so the only issue here is that we are speaking about tramway track, which by the way are different from railway track, even if the spacing between the tracks is the same. I've had another issue with this box because this box only includes 72 centimeters of straight tracks. And for me it's an issue because my bridge is a little bit longer. But anyway, I decided not to buy another box just for these few centimeters missing. I will cover the bridge with some rubble, and I think it will make the tricks just to hide the missing sections. Building these tracks is really easy, there is no problem. The quality of the mold is really nice, globally speaking. So it's rather easy to achieve each rail section. You just have to slide the rails within the tracks and glue the connectors in between each track segment. Something I didn't understand from T-Model is that they did not drill the rails for the connectors on both sides. Each rail is drilled only on one side and not on both sides. So if you want to make the connections with the appropriate connectors, which are included in the box, you will have to drill yourself the other extremity of each rail. Not a big deal, but anyway, I do not really understand the logic behind that. Here is a view of all my railway track sections, my 4 sections, with the different connectors before assembly. As I explained a bit earlier, my tramway tracks will be inserted within the foam. The reason why is that the pavement, all these cobblestones, will have to fill the space between the tracks. As I explained, I plan to realize all these cobblestones with modeling clay. This modeling clay will be applied on top of the bridge and sculpted with different molds that I created myself. So that means that my wooden sleepers won't be visible, they will be hidden below the modeling clay, below the cobblestone. An interesting detail which is not visible in the movie is that, as I explained, there is an area on the bridge which has suffered a big destruction and where a complete part of the bridge has collapsed in the river. If you look at the movie, this destruct area extends almost until the first rail section. That means that in the reality, the wooden sleepers, which extend far beyond the rails, should be visible in this area. So I started to draw on my bridge all the wooden sleepers position, just to be able afterwards to dig within the foam a small compartment to insert these wooden sleepers. I just separate one sleeper to be used as a reference to verify each compartment depth to be sure that my sleeper would reach the top surface of the foam. For easiness, it was also necessary, after having glued the rails on the sleepers, to remove all the plastics elements supposed to maintain the sleeper's alignment. I then glued all the different railway sections together using the adapted connectors. Digging the foam to accommodate the railway was quite easy, so I did not measure anything. I just cut through the foam immediately, and with my reference sleeper I adapted the depth of this hole just to reach the surface of the foam. It was sometimes necessary to make some little adjustments, especially when checking afterwards with the complete rail section. But again, no big issue with this, it's only foam, so it's quite easy to cut, enlarge or modify the depth. I already mentioned that most of my wooden sleepers won't be visible, with the exception of this destruct area. In this zone, some of the sleepers extremities will be visible. The T-model wooden sleepers are made of plastics, and I was not really fan of the quality level of the sculpted details in this plastic. You also have to take into account that the lower section of these wooden sleepers is hollow, so there is not even material there. So unless you fill this hollow section with epoxy putty or something else, you are facing an issue. Another point that I dislike with these wooden sleepers is that they are too industrial. I mean, you know, all these sleepers are perfectly aligned, all these extremities are aligned as well, and the shape in itself is perfectly the same for each sleepers. While if you look at historical pictures of railway sections, you will see that at that era, these oak sleepers were often far from being perfect. So for these visible sleepers, I've decided to cut and remove these plastic sleepers and to substitute them with balsa wood sections. It was anyway necessary to keep the steel railway fixation plate which was molded on each sleeper. Here is the work done so far. We now have to replace all these plastic sleepers by balsa sections. To care for the curvature of the bridge, because we have 2/3 of its length which are climbing and the remaining third which is descending, we need to bend a little bit the railway tracks. To achieve these results, my wife's dumbbells and air dryer made their contribution. So as you can see, just past left and right on the railway tracks with the air dryer at the hottest position, and within minutes the railway track has the correct shape. A great advantage of balsa wood is that it's a type of material which is really easy to work with. It's easy to cut, but it is also easy to sand, and it is really easy to give it some shapes and bumps and cracks and things like that. So it will be really easy to reproduce these wooden sleepers with these balsa sections. Working with sanding sticks, an hobby knife or any other metallic tool, you can achieve each sleepers being different of its neighbors. I found it a quite funny process to create these oak sleepers one by one, each time creating new damages and new imperfections, scratch, and also working with sleepers having different lengths. For this purpose, I give each sleeper a different number from 1 to 12, because I had 12 sections to replace, each number having its own position on the bridge. I then first glue each sleeper on its steel fixation plate with cyanoacrylate glue. As you can have seen, I had sculpted this fixation plate within the sleeper, as it is the case on the real oak sections. And finally, to consolidate the structure and maintain the alignment between both tracks, I glued the balsa section with the plastic section using a piece of styrene, also glued with cyanoacrylate glue. All these junctions obviously won't be visible, they will be hidden below the cobblestones done in modeling clay. So, to conclude this episode, we still have to speak about the railway to tramway track conversion. As I already explained, these rail sections were different. The tramway rail include a kind of gutter. To reproduce these gutters, I used the evergreen styrene angle section. Its dimensions are 1.5 millimeters for each side, and the thickness of the plastic is about 1.35 millimeters. No big point of difficulty here, you just have to cope with the junction elements in between the rail sections that will require a precise cut in the evergreen sheet. So after this step you just have to glue these evergreen angle section just against the rail section, which basically will materialize the gutter. The only little issue with these styrene angle sections is that they are a little bit too thin. So at scale, if you want to reproduce this gutter with the correct thickness, you will have to add a little styrene sheet against the gutter, against these angle section, with an additional 0.5 millimeters styrene strips. The final step for this conversion will be to give this rounded aspect within the gutter, and to achieve this I created a mixture of Tamiya epoxy putty and lacquer thinner from the same brand. Mixing both products together you can obtain a quite liquid paste, just like a Mr. Surfacer, but a bit thicker. The biggest advantage of this method is that you can select yourself the level of fluidity of your own mixture. This is, by the way, a very good trick to reproduce the footstep areas on aircraft wings. These areas are generally covered with anti-skid product. All you have to do is frame this area with masking tape, and then you use this mixture of epoxy putty and lacquer thinner that you apply with a paintbrush having hard bristles. Apply it randomly with the paintbrush bristle, and immediately you obtain this anti-skid surface. Leave this product to dry completely, and then all you have to do to finish the work is sand it. Well, this is it. Here is the result. I'm quite pleased with the visual effect. Now, if you have other suggestions to realize this railway to tramway track conversion, leave it in the comments below. Well, this is it for this first episode of the Ramelle's bridge creation. In the next episode, I will show you how to sculpt this bridge and how to create the cobblestones area with modeling clay. See you guys, thanks for watching and greetings from Portugal. Ciao.